Okay, so let's go ahead and take a look at this one. So these questions repeat from cosine minus sine. These questions repeat from, some of these questions repeat from 3-4b. Okay, so I'm going to take a second derivative because I want to know what the points of inflection and concavity is. So then I have a negative sine of x and then a minus cosine of x. So when I set this equal to 0, what I want is when is sine x equal to negative cosine x, or I could have flipped it around. So really what I want is one of them to be positive and one of them to be negative. So that occurs in quadrant 2 and quadrant 4. So x is going to be 3 pi over 4 and 7 pi over 4. So I'm going to go from, so interval test value, sine of f double prime of x, and conclusion. Okay, so I'm going to go from 0 to 3 pi over 4, and then I'm going to go from 3 pi over 4 to 7 pi over 4, and then I'm going to go from 7 pi over 4 to 2 pi. And it is closed brackets at the end of the closed brackets. Okay, so I can choose pi over 2. I can choose pi. And I can choose, 11 pi over 6. Okay, so now I have sine of pi over 2 is 1, so that's negative 1, and then cosine of pi over 2 is 0, so this is less than 0. And then pi, sine of pi is 0, cosine of pi is negative 1, so this becomes bigger than 0. And then 11 pi over 6, so if I were to do my triangle, root 3, 1, and 2. So then 11 pi over 6 is the 30-degree angle. And I want sine of it, so that is 1/2. So that makes it a negative of negative 1/2. And then cosine of 11 pi over 6 would be root 3 over 2. And that's going to stay negative. So then this is 1/2 minus root 3 over 2. So then I get a negative. So then f is concave down. Just kidding, down. F is concave up. F is concave down. Okay. So now I want to know my points of inflection are 3 pi over 4 and 7 pi over 4. So then I want f of 3 pi over 4, which is sine of 3 pi over 4 plus cosine of 3 pi over 4. And sine is positive, so that's a root 2 over 2 minus a root 2 over 2, which is 0. So that f of 7 pi over 4 is, let's see, so 7 pi over 4, so that's a sine of 7 pi over 4, which is negative root 2 over 2. And then plus cosine of 7 pi over 4, which is a positive root 2 over 2, which is also 0. So f is concave up on 0 to 3 pi over 4, union 7 pi over 4 to 2 pi, and then f is concave down on the interval from 3 pi over 4 to 7 pi over 4, and then f has points of inflection at 3 pi over 4, comma 0, and 7 pi over 4, comma 0. Okay? All right. Moving right along. This one was so bad. I wish I hadn't done it to you guys. And then we only have one more after that. Okay, so if we take a look at this, and the reason why I say it's terrible is because it's like 6 one way, have it as in another. And I did it for somebody in class. But I think when I look at it, I'm not going to want to do a bunch of product rules. So x squared minus 4x plus 4. And then x squared minus 8x plus 16. I think I'm just going to multiply this out because it's a lot. So f of x to the 4th, minus 8x cubed plus 16x squared minus 4x cubed plus 32x squared minus 64x. Yes. And then plus 4x squared minus 32x plus 64. I think that all works out, right? 4x squared, negative 32x. Yes. So then what I get is f of x to the 4th minus 12x cubed (36 and 16), so that gives me 52x squared minus 96, just kidding, 96x, and then plus 64. Okay, and I'm going to attempt to check my arithmetic just one time here. Okay, so I'm going to take a derivative. So I have f prime of x is equal to 4x cubed minus 36x squared plus 104x minus 96. And then I'm going to take another derivative again. So f double prime of x is equal to 12x squared minus 72x plus 104. Okay. Okay. So now I want to factor. So 3x squared, 72, pull out a 4, 1, 4, 32, so 18. And then 104 divided by 4, 2, 8, 24, so 26. Yeah, okay. So I said this is equal to 0, which is going to require the quadratic formula. Like 3, no, okay. So I'm going to have to use a quadratic formula. So negative 18, so 18 plus or minus the square root of 18 squared minus 4 times a times c all over 2a. Okay, so sad. 18 plus or minus the square root. Let's see, 18 times 18, 64, so 6, 144, 8 and 1, so 324. 324 minus 12 times 26. 21742. 312. 324 minus 312 all over 6. Okay, so 18 plus or minus, let's see, 324 and 312 is 12. Root 12 over 6. So that is 18 plus or minus root 4 times root 3 over 6. So that reduces, that gives me 9, that gives me 3, so then I get 9 plus or minus root 3 over 3. Okay, so I really did not intend on that last one being so weird. So I'm just going to say that if you end up skipping that question, that's totally fine. I did not expect it to look like that. That is such a epic mess. Okay, so let's practice with this one. So let's do f prime of x is equal to 3x squared plus 6x minus 24. F double prime of x is equal to 6x plus 6. So x is equal to negative 1. Okay, so I have interval. See, all of this was supposed to work out like this. Test value, sine of f double prime of x, and then conclusion. Okay, so now negative infinity to negative 1, and then negative 1 to infinity. Okay, so now I'm going to pick my test value. So x is equal to 0. No, just kidding. X is equal to 0 here. X is equal to negative 2. So that f double prime is going to be less than 0 here, and then bigger than 0 there. Okay? So that means concave down, and then concave up. Okay, so nope, we got to find the points of inflection first. I have to figure out what f of negative 1 is equal to first. So negative 1 cubed plus 3 times negative 1 squared minus 24 times negative 1. Okay, so f of negative 1 is negative 1 plus 3 plus 24. So that gives me 26. Okay, so f has a point of inflection at negative 1 comma 26, and f is concave. Oopsies. Concave down on the interval from negative infinity to negative 1, and f is concave up on the interval from negative 1 to positive infinity. Okay, and that's it for this section.